Hi there and welcome to today's class. For this class, we'll try to prove some trig identity, right? So I have created a series of video in the study of trigonometry, right? So if you're interested in watching our full course on trigonometry, you can simply hit the link you are seeing above you here. I'll drop a link above you here. So that link will take you to our full tutorial course on trigonometry. All right, for this class, we're trying to prove this to identity. After the proving of this identity, we'll move to what we call the quadrant, right? We move to quadrant, the concept of quadrant, right? So by the way, let's prove this identity. That is first, for number one there, for A, I have that cot theta plus cosec theta all squared is equal in value to 1 minus cos theta all over 1 plus cos theta all over what there? 1 minus cos theta. So the idea is that I'm picking out the left hand side equation, right? So I'll pick out this one here such that I will break it down until I have this expression. So the idea is that I'm trying to prove the left hand side being equal to the right hand side. That becomes the concept. So how do you solve this problem here? Let us first, I'll pick out this one here. So I have cot theta plus cosec theta all squared. From here, what we know before now is that in trig identity, as we discussed in our last class, that if I have cot theta signifies 1 over tan theta. This is the first significant for cot theta. I can also represent cot theta as being equal to what? Cos theta over sine theta. These are the two expressions for what's it called? Cot theta. So it means that now at this point now I will express cos theta in that form. So I can use any of these two, right? If I use this one, I will end up having this one. So let's go for what? This man here. So replace cos theta as being equal to replace cot theta as being equal to cos theta over sine theta. That becomes the concept. This for cot theta. We also have cosec theta. We said in the last class that cosec theta signifies what? 1 over what there? Sine theta. So I'll put these two into that expression there. So what do we get? From here now, I'll have that cot theta now becomes what there? Cos theta all over sine theta. The expression for this one becomes this, plus I have a plus sign, plus next up cosec theta gives what there? 1 over sine theta. I have this one there, all squared. All right, at this point here, what's next task? That is first, observe that I'm having a fraction here. So when you have two fractions, either being positive or negative at the center, what comes to mind? LCM comes to mind. So per se, I'm having the same denominator. I'll just pick as what? Just one value there. So my LCM here, LCM becomes what there? Sine theta all over what there? Combine these two. That's cos theta plus, what's it called there? Plus 1. Don't forget, we still have a square. As in this case, this square comes down here. I have this one here. Don't forget that we're trying to prove this man here being equal to this. So let's break this down such that we expect our answer should be this. Let's now see if that is true. From here now, I will apply the concept of indices. What we know generally before now, is that if I have A over B all squared, applying your indices concept, what comes to mind? I'll have A squared all over what there? B squared. These indices. The same technique applies here too. What's the technique? This can be expressed as cos theta plus 1 all squared all over what there? Sine theta all squared. Sine theta all squared can be written as what? sine square theta. So per se, I'll write that what? As being sine square theta. So I have this one here. At this point, what we know, before now, we discussed about the concept of trigonometry identity. There are three formulas, all right? So recall that we said that cos square theta plus sine square theta is being equal to 1. No problem. I'm saying sine square theta here makes sine square theta subject. What do I get? Sine square theta is being equal to 1 minus cos square theta. It means that anywhere I see sine square theta, I can replace it as being equal to what there? 1 minus cos square theta. So put this man down here. So I'll have that cos theta plus 1 all squared all over sine square theta gives what there? Gives what? 1 minus cos theta. 1 minus cos squared theta. All right, at this point here, what comes to mind? What comes to mind here is that observe my numerator and denominator. For my numerator, I can expand it. What do I mean? If I have a plus b all squared, this can be broken down as what there? A plus b into a plus b in expansion form. Expand this one here, it means it occurs twice. So have what there? Cos theta plus 1 into what there? Cos theta plus 1 all over. From here, apply the cost of difference of 2 square, right? So it means that for this one, I'll be having what there? 1 plus cos theta into what there? 1 minus cos theta. Let me explain why this is so. I have 1 minus cos squared theta. This is square here, right? Perhaps if I put a square here, 1 square is still 1. So apply the idea of different. We know that minus means different. So this is different of what? 2 squares. So for difference of 2 square, because what? That 2 thing plus that 2 thing minus. As you can see, this expression plus and what? And the minus 1. From here now, I can see that this plus cancel out what? This one here. What am I left with, please? I'm left with what? Cos theta plus 1 all over there. 1 minus cos theta. Please help me check, compare this. So I have this man here. This is how to prove this expression here. Let's do 2 and let's end this class. For number 2 there, for B, what do I get there? I have sec theta minus 1 all over sine square theta is being equal in value to sec theta all over 1 minus what there? Sorry, 1 plus cos theta. All right, let's prove this one, please. We are trying to prove this one to be equal to this. As you can see that we proved that this man here is equal to this man, as you can see. So let's try to prove this left hand side being equal to right hand side. What do you do? First, the idea is that let me make this board a revision, like just revise all this concept. Let me remove this. All right, for me, what do we get now? Let's try to prove this one, please. Pick out this, please. Do not pick the right hand side equation, please. You are proving the left hand side, please, being equal to right. So always pick out what? The left hand side equation. So I have that sec theta minus 1 all over there sine squared theta. From here, what do we know from here? We know that I can express sec theta as being equal to what there? 1 over what there? Cos theta minus 1. I have my numerator as this. All over sine square theta means what there? It means 1 minus cos squared theta, as we used earlier. Now sin squared theta we give what there, 1 minus cos squared theta. Similarly applies here too, so I have this one here. All right, at this point here, what your next task? Observe that we apply the concept of difference of two square here. The same thing applies there. For this one here, apply difference of two squares. What do you get? Drop this down. I have one. So okay, hang on. Let's try to simplify this one first. Of course, it's an invisible one here. The LCM here becomes what there? Cos theta. So I have cos theta as being my LCM here. Cos theta divided by cos theta is what? 1. 1 times 1 is what? I have 1 here minus, what give me here? I have what there? Cos theta. That is cos theta divided by 1 is what? Cos theta times 1 we give cos theta. So the expression of the numerator is this one here. So all over, we said this can be expressed as what? The idea of what? Difference of two squares. So I have 1 plus cos squared theta, 1 plus cos theta into what there? 1 minus cos theta. So I have this one here. So from here, I will apply the idea of what's it called? I will apply the idea of reciprocal. From the idea of reciprocal from our primary school, we know that if I have, observe please, if I have A over B divided by C over D, what do we know? Change man what to times. So have A over B times what? D over C. Observe, D comes up, C goes down, as in this case. Apply the same technique here. Drop this man down. I'll have 1 minus cos theta all over, cos theta. Everything here is this. This symbol signifies what there? Division. Drop this one down. I'll have 1 plus cos theta into what there? 1 minus cos theta. There's an invisible one here, of course, right? So change this division to times. What do we know? This will invert. So we'll have that. From here, I'll have 1 minus cos theta all over what there? Cos theta is times this 1 comes up. There's an invisible one here. So the 1 comes up. I'll have 1, right? All over there. Over 1 plus cos theta into what there? 1 minus cos theta. So from here, we know that this one here can cancel this man here. So what do we get here? 1 times 1 we give 1 all over, all over there, cos theta times this we give cos theta into 1 minus plus cos theta. I have this one here. From here, don't forget that I will try to prove this man here, right? So my task now is I'll separate these two. How do I separate it? I'll pick 1 with this. So 1 all over cos theta multiplied by 1 over 1 plus cos theta. 1 times 1 is 1. This time this is this one. This and this are the same thing, but what? Different in expression, right? So what do I get here? From here, don't forget we said 1 over cos theta is what? That's what there? Sec theta. Don't forget the identity. No, we said that sec theta is equal to what? 1 over sin theta. 1 over cos theta, right? So this one gives this one multiplied by 1 all there. 1 plus cos theta. What do we get, please? I'll have 1 times this is what? Sec theta all over what there? 1 plus cos theta. This becomes the proof to this particular question here. So this is to prove something of this nature. All right. See you in the next class. We're talking about the concept of what? Quadrant of angles in our next class. Oh, sorry, per se. We're talking about the concept of special angle. Please, reading from the special angle, reading from the angle 30 degree, 60 and 45 degrees, right? And we're looking at how to apply them in our solvings. So see you in our next class.